I'm going to kind of talk about, and I already know that we kind of did this on Friday, so that's why I don't think we probably need to spend a lot of time with it. But it is a couple of things they talk about in this lesson, and you got a couple of problems that ask about this. Not overly difficult things, but just some terminology and things like that we need to be aware of. Even though we introduced matrices on Friday, the big topic here is matrices. We just did it a section early since we didn't solve by hand. The first thing is what we call the order of matrices. And when we name a matrix by its size, we always say rows times columns. List rows first. How many rows is it across? And then columns are up and down. And it's a big deal because if I had something like this, we would call this a 1x3 matrix. It has one row across and it has 3 columns up and down. Okay, and it's not a bunch of rows or a bunch of columns, but crossed and then going up and down. If I went the opposite direction, this one is a 3x1 because it has 3 rows across and just 1 column up and down. And so same numbers, but a little bit different order. And so that's going to be important, like when we put it into our calculator and when we do it, we want to make sure we put in the right numbers. So we're putting in the right size of matrix. Another big one here is what we call an augmented matrix. And this is what we eventually did on Friday. But today we're going to talk about going back and forth. And these problems, when you see them on your homework, are not going to necessarily be a lot of work, but it's just being able to recognize how we're going to write it. You're going to have some equations given to you, and we want to change that equation to a matrix. And what we do is we write it in as an augmented matrix. So if I were to write up all the problems that we did on Friday, or in 6.2, were all 3 variable equations. Today we're going to see some that are only 2 variable, kind of like we did in the very first lesson when we did elimination, substitution, and graphing. So if I change this to a matrix, because we have 3 variables, we're going to change this into a 3x4 matrix. Basically, the top column is going to be your x values, then your y values, then your z values, and then your last column is going to be your constants. And we're going to have 3 rows across, which are the 3 different equations. Because I'm missing a y value right here, I would treat that as like a 0y. And we have to include that in our matrix. So sometimes we don't have all the variables included. So we're going to go 2, 0, 3, negative 8. We're just putting in the coefficients. When we put it into the matrix, we don't put any variables attached to it. If there's no number in front of the y, then we assume that to be a 1. So that'd be a negative 1. So we got 4, negative 1, 6, then 7. And on the last equation, we don't have any x's, so we're going to put 0 in for x, 9, 4, and 1. Okay. So this one is a 3x4 augmented matrix. I always put these dashes in here because that's where like the equal sign would go. And when you put it in the matrix, they won't necessarily put those dashes in there, but it's something I always like to do. It separates the variables from the constants. Do you have to put it in there? Not necessarily, but I always like to do it just as kind of a reminder. That's where the equal signs would go. As you solve it, that would kind of help you as well, and I'll show you what I mean by that in just a second here. Okay, the other thing we're going to do, though, is we're going to go the opposite way. If I gave you a matrix, this is one that we did not see on Friday. We only saw 3x4s, but we saw some problems like this on the first lesson, on 6-1. Now we're going to go the opposite direction. We want to write this matrix as an equation. What equation would this matrix represent? Or set of equations? In this case, there's only two variables. So this would be my x, this would be my y. There's not a third variable, a third column here for the z's. So what we would say here is 2x minus 3y equals 6. And then 4x plus y equals 7. And that would be the set of equations that it would represent. Okay. So not overly difficult stuff. There's not a lot of work involved. It's just being able to rewrite it from one form to another. What equations is represented, or what is the matrix that would represent the equations, are the questions that would be asked on something like that. And we are going to see it today with both 3x4s and with 2x3s. Those are the only two types of matrices that we're going to solve. It's either a 3x4 or a 2x3. No other types of matrices that we're going to solve. On Friday, I think there was some in there that were like 4x5, but I don't think I assigned any of those to you because we're not going to go that big. All right, I'm going to put a couple of examples up here and just kind of practice some of these on your calculator. Make sure we know how to do these. I'll write down. I'm just going to pick some kind of from. So let's say we have 4x plus 2y equals 11, and 3x minus y equals 2. Okay. Most of the ones that I gave you on Friday only had integers in the answer. Okay, I don't think I gave you too many that had like fractions or decimals, or maybe none. This one, I just want to show you the answer is not necessarily always going to be an integer. So if I were to do this one, first of all, and we're just going to use our calculator to solve today. So that's kind of the good news, is we're going to put in 4, 2, 11. We're going to go 3, negative 1, 2. This is my x, this is my y, this is my constant. Okay, so if you get your calculators out, we're going to put this in as a 2x3. And what we're looking to do is we're trying to take RREF of whatever the matrix is. So if you put it into matrix A, then you're going to do the RREF of matrix A. Make sure that you do, there is a button that says REF. We want the one that has 2 R's on it. You don't necessarily need to know what this stands for. I'm never going to ask you probably, but it's reduced row echelon form is what it stands for. There is a reason why it's called RREF. Reduced row echelon form is always going to look like this. Okay, you're going to have ones in these two spots. The reason why is because this 1 represents my x value, and this 1 represents my y value. Okay, and so we always want our left-hand side when we do the RREF to look like this, and sometimes it won't, and we'll talk about that here in just a second. Okay, but if we do it, you should get two numbers over there. They might be decimals. If you want to change, you could go, especially if it was repeating decimals, you could go math, you could take the whole matrix and go math frac and change it from a decimal into a fraction. So anytime you have repeating decimals, that would probably be my go-to, is math frac it just like you would any other. And they can change it to fractions for you. Fractions would probably be the best way to write out the equations. Okay, everybody able to get those okay? And so you may not always get integers. Don't freak out if you don't get integers. And this one's a little bit different because it's a 2 by 3. For a reduced row echelon form, if it's a 3 by 4, and this is what we saw on Friday also. This is X, this is Y, this is Z. So this number here is going to represent your X, this number is going to represent your Y, this number is going to represent your Z. This is what we want the left-hand side to look like. You always are going to have a diagonal of ones going from top left to bottom right. All the other spots should have zeros in them. If your left-hand side doesn't look like that, that means we have a different kind of solution, right? And so the majority of the time, this is what your solution should look like, and then your answer are just the numbers over here. Okay, this is what it would look like with the 2 by 3. This is what it would look like with the 3 by 4. But we know from last week that we could have a solution that's not always gonna be an ordered pair or an ordered triple. Here, we would write our answer as an ordered pair, like we're used to. This is your X, this is your Y, so we would just write it as 3 halves, 5 halves. When we do an ordered triple, we always write it as X, Y, Z. Just have a third number involved. Okay. All right, let's look at, let's put another one up here. Okay, let's put this one into our matrix once again. The matrix is going to be 4, -8, 12, -1, 2, -3. Really watch those positives and negatives and things like that, because that can really affect, obviously, your answer. Okay, this is why it's really important to understand what the matrix is telling you, okay? In this case over here, as I looked at the left-hand side, and this is why I like drawing the dashed lines in here that don't show necessarily up on your calculator, is remember this should be 1, 0, 0, 1. This is obviously not 0, and this is not 1. Okay, so something is wrong here. That doesn't mean I necessarily typed it in wrong, it just means there's a different solution here. And so as I look at the bottom row, this is really essentially saying 0 equals 0. So if I say 0 equals 0, because that dashed line represents the equal sign, if I said 0 equals 0, what type of solution would we have here? Infinitely many, okay? And I told you I was okay if you write it like this. They write infinitely many solutions a little bit different. I'm not going to make you write it the way they write it, and so you can simply just write infinitely many solutions, and that would be okay. Okay, I'll show you what a no solution would look like as well. 6x plus 2y equals negative 10, negative 3x minus y equals 6. This would definitely be one that you would want to do math frac with because of the decimals that you get. Okay, once again, dead giveaway is it's not in reduced row form, right? The left-hand side doesn't look like it's supposed to. On this bottom row, we have 0 equals 1. Right where that is. This is not true, so this would be a no solution. Okay? So just understanding the difference between a no solution and a mini solution, they're very, very similar, but it's a dead giveaway when the left-hand side doesn't look like we want it to. Okay, so that's how you can tell from matrices when we have one of those special types of solutions and it's not going to be an ordered pair. Okay, everybody good with that? Calculator-wise, any questions on any of those? All right, the last thing I'm going to go through with you here is I'm going to do a we're going to do a problem with matrices with the story problem, and then I want to show you something that will be on the quiz that we're not going to use matrices for, but we're still going to use the calculator for it because there's an easier way to do it rather than using a matrix for it. Okay, so the first thing is, this is number 41. If you have your books, you can look at it. If not, I'll just kind of read through it and talk about it on page 436. On the homework today, I think I'm going to give you a story problem. On the quiz, in the quiz review, you'll have some story problems to do as well. Getting the story problem set up is the hard part. If you can get it set up, then you can use your calculator to solve it, and I'm totally fine if you want to use it. Probably wouldn't want to do substitution elimination to solve some of these. So I'm going to absolutely let you use your matrix to solve these. Okay, we have to decide, like, basically, is it a two-step or a two-variable or a three-variable equation? In this case, we're talking about this manufacturing plant that borrowed $30,000 to buy a new piece of equipment. Part of the money was borrowed at 8%, part at 10%, and part at 12%. So we have three unknowns. And so the first thing I'm going to do is I'm going to say X is the 8% money invested, Y would be the 10% money, and Z would be the 12% amount. Okay, so those are my three unknowns. Now, we're going to have to read through it. We're going to have to set up equations that represent this. But because I have three variables, here's the thing you got to remind yourself. If I have three variables, I'm going to have three equations. Okay? If I have two variables, I'm going to have two equations. And that's always going to be the same. Okay? If you don't have three equations, then I got to figure out what's my third equation going to be. The total amount borrowed is $30,000. So the first equation here is pretty simple. Those three amounts have to add up to be $30,000. Now, it's not going to probably be as simple as saying 10,000, 10,000, and 10,000. It doesn't necessarily say we're borrowing the same amount of each. We just know that the three amounts total up to be $30,000. Okay, the total interest. And this could be a problem where it's interest paid or interest earned. Like if it was an investment account, it could be how much money am I making on my investment account. But in this case, it's a loan. So I'm borrowing money from the bank. So this is how much interest I'm paying the bank. If I borrow 8% from a bank, simple interest, how would I figure out how much interest I'm going to pay that bank? What would I have to do? You would have to take 0.08 times the amount borrowed. But we don't know the amount borrowed, so it's just 0.08 times x. That's why I think it's a good idea to set up these. So what do each one of these represent? So I know x is 8%, so I'm going to take 0.08 times x. And then I'm going to take 0.10 times y. And I'm going to take 0.12 times z. And the total interest paid for those three loans is $3,040. So we borrowed $30,000, we're paying the bank $3,000 for the loan. The total amount, and here's the last equation. The total amount borrowed at 8% and at 10% was twice the amount borrowed at 12%. So this equation would look like this. X plus y equals double the amount of z. And so that's kind of weird, right? Because we're saying these two together are double the amount of z. And what's weird is that z is over here on the right-hand side. But it's kind of like when we do anything, when we solve in quadratic or whatever. We always want to set it equal to 0. Well, same thing here. When I set up my matrix, I want x's, I want y's, and I want z's to all line up. Right now, z is over here. So what do we got to do? Well, we got to bring z back over, okay? And so I'm going to subtract 2z from both sides. So this equation really becomes x plus y minus 2z equals 0. And that would be my third equation. But you've got to do that part where you set it up. Okay, so now try putting this into your matrix. All right, so we should get x is 8,000. 10% is 12,000. And 12% is 10,000. Everybody able to get that okay? Did you guys get those numbers? Okay. So the solving part is not the hard part, right? It's just a calculator. Put it in just like any other matrix. The harder part is to get the equation set up. If you don't get the equation set up correctly, then it doesn't really matter what you put into your matrix. You're not going to get the right things. Okay. How you could check this is these should add up to be 30,000. So if it doesn't make sense, well, 8 plus 12 plus 10 adds up to be 30. Okay, so 30,000. If you put it into the other equation, it should work as well. These two added together should be double of this. Well, these two added together are 20,000, and that's double of 10,000. Okay, so it satisfies and matches all the equations that we had. All right, the last thing I'm going to put up here is one from, it was actually on 6.2. They show you how you can do this by matrices, but I'm not going to have you solve this by matrices. We're going to use a different method because I think that this method is a little bit easier. All right, and so this one is on, if you got your book, you can look at it. If not, I'll just talk about it. Page 428, number 34. It gives us a table. And it's talking about the number of motor vehicle deaths over the course of time. And they want to see if there's any kind of data or some type of relationship that's going on here. And so it tells us in 2016, we call that year 0, okay? And it says, and this information is provided in a table right here. 2019 is 3 years down the road, 17, 18, 19. And then finally 2021 is 5 years later, 5 years after 2016. This is 39.1, and this is 47. Okay, it says to use a system of equations. So it wants us to kind of like write out a system of equations to represent this. But I'm not going to do it that way because I think there's an easier way to show this that I think you guys have done before. We want to write an equation in this format, okay? What type of equation do we have here? Anytime we have an x squared, what do we call that? Quadratic. It doesn't necessarily use that word, okay, but this is good old quadratic equation, right? When we solve quadratic formula and we did all that, that's what a quadratic equation is going to look like. Sometimes it'll say quadratic equation, this one does, but not all of them may. So we're going to try to write a quadratic equation that represents this relationship, okay? So part A is to write the equation. So the first thing we're going to do, let's go to our calculators. We're not going to use matrix for this one, okay? We're going to use a little bit different method here. We're going to go to Stat. We're going to go to Edit. And we're going to put these numbers in L1 and L2. Okay? But the numbers we're going to put in on the left-hand side would be the single numbers. We're not going to put in the actual year. We're going to put in how many years have passed. And so year 0, year 3, year 5. Don't put in the actual year. The deaths, you put those numbers in. Okay, get out of that. So on TIs, you have to hit second quit or just get back to your home screen. Okay, then we're going to go back to Stat. We're going to go to Calc, so you got to go over to Calc. And the reason why we talked about this is because we're looking for a quadratic equation. And the quadratic equation is quadreg. We call it quadreg because it's a regression equation. So that's where the REG comes in. Quadratic regression means you're going to get a quadratic equation. And you'll go to calculate, and it should then give you 3 values for A, B, and C. Okay, and if you wanted to know, does this make sense? Well, this is my starting amount. And if I look at my starting amount, look at my table, right? 40.3 is where it started. So that would be your equation. Part B says, estimate what the number of deaths would be in 2018 and then in 2022. Well, 2018 would be x equals 2. 2022 would be x equals 6. We just got to go back to our original table. 18 is 1 year before 19, so it would be 2 years later, okay? 2022 would be 6 years later. So all I got to do is take these two numbers and plug it into that, and that would give you your deaths. Now, the numbers here, if you are wondering what, that's not really making sense, this is the number of deaths in thousands, so this would be like 40,000 deaths. And so that way we don't have to put in like big long numbers. But if they ask you how many thousand deaths happen, or if you wanted to write your answer, so like for instance, this one, when you plug this one in, you might get like 37.8, but that means 37,800 deaths, just so you understand what it means. Okay. It's not 37.8 deaths. It's a lot more than that. And that's for the whole United States, so quite a few. Okay? Everybody able to get that okay? Everybody kind of remember how to do that in their calculator? Okay, it's not a big deal, but it's not a matrix, so it's a little bit different process to do that one. And there's only going to be one like that on the quiz. Just a way of, there is a way to do it on the matrix, but I think this is much easier. Yeah. So you got it all. So yep. Now we'll go to Greg. So hit that green. And we're going to do X squared because X squared is quadratic. And but Cassios and Bale, did you? Okay. If you need help with your calculators, either matrices or on the stat part, just let me know and I can help you out. Okay. All right. Assignment for today. Okay, on all of those, you can use the RREF. On 1 through 13, you're not solving. You're just saying, what's the size of the matrix? And then you'll have a couple of those where you change it from, you have an equation given to you, you have to write what the augmented matrix would look like, but you don't have to put it in your calculator. And then you have some where they give you the matrix, you have to write the equations. So the first 1 through 13 are just rewriting some different things. And then starting at number 15 is where you're going to solve, but you can use your calculator on all of those. Okay. I didn't give you any where you have to do the stat. There will be one like that on the review tomorrow, so if you need to review that, you can. I just didn't put any of those on your assignment today because it was from 6-2. The problems would have been from the previous day's lesson, so I left that off. All right, if you need help with your calculator, let me know. I can help.